Hey class. So welcome to day 3 of eSchool. It's going by pretty quick, huh? We don't have that many more lessons left. But I really wanted to, first thing first, stamp what we've learned so far this week, all right? Before moving into our next topic, which is multiplying polynomials. So in day 1 of eSchool, we discussed this concept of like terms, all right? Where like terms are some combination of coefficient, variable, and exponent where the variable and exponent match. We learned about how to combine like terms. We learned that when you combine like terms, only the coefficient changes. All right. We then learned how to add and subtract polynomials, where polynomials are any combination of terms with exponents, variables. Pretty much any polynomial is more than one term. All right. So when we were adding and subtracting polynomials, we had this idea that you have to add and subtract only like terms. So those first 2 lessons really worked well together. During the direct instruction yesterday, we went through a ton of examples of how to add and subtract polynomials. We also talked about some tricks of the trade, some helpful things, kind of like what's negative minus a negative, right? Things like that. I know that can be really tricky, especially in algebra. So I really want to make sure you guys understand that, so please feel free to ask questions. Okay? So moving on to today's lesson, we've done adding and subtracting. We're now going to multiply polynomials together. Guys, this is a super cool concept and something that I think you guys are going to find really helpful moving forward into other things you do. Okay? So let's start by going over an example. All right? Easiest way to learn this is by practice, practice, practice. So let's take an example. Let's say we have a polynomial of 2x plus 2 multiplied, right? When these parentheses are here and there's no plus or minus, this means multiplication. You can even put a dot or a cross to depict multiplication, but this is the easiest way to do it and the most accepted. All right, so we're going to multiply this by 4x plus 6, okay? Now, whenever you're multiplying polynomials, the first thing you're going to want to do is pick one of these over here, one of these terms. So let's say we pick 2x. And then you want to make sure that you multiply that 2x by everything in the other term. So you're going to multiply 2x by 4x, and then 2x by 6. After that, you're then going to choose the next term, 2, multiply it by 4x, and it by 6 as well. This is going to give you a complete set of terms that is equal to the multiplication of 2x plus 2 times 4x plus 6. So let's go through this in very detailed steps. So our first step, we said we're going to take this 2x, and I want to multiply it by 4x, and I want to multiply it by 6. So the first thing, let's label this 1. 2x times 4x is going to give me 8x squared. Okay? 2x times 6 is going to give me plus 12x. Then, so this was 2. Let's do 3 as 2 times 4x plus 8x. 2 times 4 is 8. No other variable there. Plus 2 times 6, which is 12. Now from here, everyone, we can now combine like terms, where the only like terms we have are these two, which will combine to give you 20x. So finally, we can rewrite this as 8x squared plus 20x plus 12. Now, I know we kind of just jumped in and did this problem, and there's some steps here that may have been a little confusing. For example, why when I multiplied 2x times 4x, did I get 8x squared? Okay, so let's break this down. I want to multiply 2x by 4x. When you multiply two numbers or two terms like this, you know that this 2, first thing you're going to write is the 2 times the 4. All right? That's going to give you an 8. And then you're going to multiply the x by the x. Now, anytime, so let's put a note down here. Anytime you are multiplying variables with exponents, the exponents add. I'm going to say that again, guys. Anytime you multiply variables with exponents, the exponents add together. So here, x to the 1 times, excuse me, we can't do a multiplication like that with an x. X to the 1 times x to the 1 is going to give me, I'm going to keep the x there, the variable doesn't change, but the exponent does. So this is going to be x times 1 plus 1, which is equal to x squared, right? As another example, let's take x cubed times x. Once again, my variable x doesn't change, so I'm going to get x over here. But my exponents, the 3, adds to the 1. Remember, you can always write a 1 when there's nothing up there. So this would be 3 plus 1, which is equal to x to the 4th. Guys, another way of writing this, just on the off chance this makes more sense to you guys, is decompose the x cubed. Take x cubed and rewrite it as x times x times x. Now, that's x cubed, and I want to multiply by 1 more x, and then count them all up. That's going to be 1, 2, 3, 4, which is equal to x to the 4th. Whichever way you find makes most sense here, that's what you should do. But the key here, guys, and I'm going to make this and box it in over here, is when you're multiplying variables, the variable doesn't change, so x will not become y, but the exponent does. All right, so the variable doesn't change, but the exponents add together. All right, so let's go through a couple more examples of this. Let's go with one more, actually, okay? So let's take x to the 6th, that's a big one, multiplied by x to the 4th. All right, remember, I multiply these together. Does my x change? No, right? My x won't change because up here I say variable does not change. So this is going to give me x. Now what about my exponents? They add, right? So that's going to be 6 plus 4, which is equal to x to the 10th. All right. If we want to write this out more explicitly, you could write this as x times x times x all the way up to 6 x's. All right, multiplied by 4 more x's from this x to the 4th, x 4 times. You can do something pretty cool here and just add them all up. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which leaves me with x to the 10th. All right. So hopefully that was a little helpful in like explaining how you multiply a variable by another variable. All right. But that brings us to kind of another complication. Say you didn't have x times x. Say instead that you had this as x squared y multiplied by x y squared. You're only going to multiply, so this x squared is going to multiply to the x, and the y is going to multiply by the y squared, right? So when you do this, this is going to come out to, remember, the variable doesn't change, so x squared times x is going to be x to the 2 plus 1, where I've added 2 here and the 1 here, multiplied by the y to the 1 plus 2. All right? So when you do this, you're going to get x cubed, y cubed. As this can be pretty tricky. it's important to know that when you multiply terms that have two variables, the exponents only add with like variables. So the x variable is going to the x exponent is going to add to this exponent. The y exponent will add to the y exponent. Let's do one more example of this. Let's say we add in a level of complexity. Let's say we have x squared, y squared, z, so that's my first term, multiplied by x, just x, y squared, z. All right? Remember, the only time the exponents add are when the variables are the same. So I'm going to write over here, I know it's going to have the three variables x, y, and z, but what goes up here? So the first thing is for the x, I'm going to add the 2 here to the 1 here. So 2 plus 1 should give me 3. For the y, I'm going to add the 2 here to the 2 here. That should give me a 4. And for the z, you're going to add the 1 here to the 1 here. 1 plus 1 should give me 2. So that leaves me with x cubed, y to the 4th, z squared. Guys, I know this can be tricky, so please ask some questions, okay? All right, let's go ahead and come down here and do a couple more examples of full multiplication of polynomials. So here, let's start with the idea with 2x squared plus 3x plus 1 multiplied by x plus 2. All right? A trick here, everyone, is you're always going to want to start with the polynomial with the least amount of terms. So I'm going to rewrite this as x plus 2 times 2x cubed, 2x squared plus 3x plus 1. All right? Now, I'm going to do this in very high detail. I'm going to take this x, I'm going to multiply it by the 2x. I'm going to take the same x, multiply it by the 3x, the x again, and multiply it by the 1. All right, so let's write down here, we've got x times 2x is going to give me 2x to the 2 plus 1, which would be 3. The x times the 3x is going to give me plus 3x squared. Well, once again, I've added those exponents, 1 plus 1, plus x times 1 is x. That's the first thing. All right, that's the x distributed to everything. Now, let's take the 2. Okay, I'm going to multiply the 2 by the 2x squared. 2 times 2x squared is going to give me 4x squared, so plus 4x squared. 2 times 3x is going to give me plus 6x, and 2 times 1 is going to give me 2 plus 2. All right, so now I've distributed this to each term individually and written it out down here. Now let's go ahead and group like terms, starting way over here on the left with 2x cubed. Do you see any other term here that has an x and a cubed? I check here, 2, nope, x to the 1, nope, x squared, nope, 6x, no. No more 2x cubed, so down here, my first term is going to be 2x cubed. Now, I check my next term, 3x squared. Do I have any terms that match with 3x squared? I've got 4x squared over here, so I know that matches. And there's no other x squared, so I'm going to add 3x squared to 4x squared, which will give me 4 times 3, or 4 plus 3, excuse me, which is 7, plus 7x squared. All right, another term here, we've got plus x, and I see that I have an x over here as well. Another real kind of tip here, guys, is if you want to cross them out as you go, it's never a bad idea. So now I only know that I have these 3 terms left. I know that x matches with 6x, so I can combine those to give me 7x. And lastly, I'm left with this 2 on the end, which has no more matching terms, and I can just leave it as plus 2. All right, so I'll do that again. So guys, I'm going to make another video with more examples for you all, but this is where we're at right now.